So today we're starting chapter 3, which is the chapter on matrices. And before we get into matrices, we need to do a very brief review on solving system of equations using substitution and elimination. There will be a couple questions on your chapter 3 test that will involve that, but it also is a good lead-in into how we can use what's called matrices to solve systems of equations as well. So first review, we're going to look at substitution. Let's just practice one of these on here. If you want to solve a system by substitution, you want to make sure that the letter is by itself, either the x or the y. This one, for instance, is already set up with x by itself. This one is not, so I want to do this one instead. If you want to get y by itself, add the 2x to get it to the other side. And then when you do substitution, you circle that piece, that whatever letter you got to be by itself, you circle that piece, plug it into the other equation that you did not use in place of that letter, and then rewrite. 3x plus 2 quantity, 2x plus 4 equals 1. 3x plus 4x plus 8 equals 1. 7x equals negative 7, x equals negative 1. And remember, you're solving a system, so that's the first piece to your answer. X is negative 1. Then you need to go back in and plug in the negative 1. Easiest place to put it is your circled stuff. 2 times negative 1 plus 4, negative 2 plus 4 is 2. So the solution to this particular system is negative 1, 2. All right, your next type of system we're going to solve with is elimination. You can solve elimination. The word eliminate obviously means to get rid of, so if you have numbers that already match, what can you do to get rid of that particular number? Like in this one right here, you have a positive 2 and a negative 2. You could add these two equations together and you would totally eliminate the y term. You're adding up and down to get your solutions. So this one is an easy one that's set up. This second one over here does not have numbers that match, so you need to try to make those numbers match somehow. So for instance, if I choose the x value, what could I get each of these x numbers to say where they match? I could get them both to say 6. So I'll times this whole equation by 2, this whole equation times 3, and then do a great big distribution all the way across. 6x minus 10y equals negative 12. And then on the second equation, negative 6x plus 21y equals 12. I have a positive 6 and a negative 6. In order to eliminate those, I again would have to add. 6 plus negative 6 would get eliminated. Negative 10 plus 21 is 11y. And then negative 12 plus 12, 0. And dividing, we get 11 equals 0. So the first piece to our system is y equals 0. And then when we plug the 0 back in, you can pick whichever equation you want. It doesn't make any difference. I'll just choose the top one. 3x minus 5 times 0 equals negative 6. X equals negative 2. So the solution to this system is negative 2, 0. Now there are a couple exceptions to the solving system rules. We'll look at both of those two exceptions right here. Neither one of these numbers match whether I choose x or y. So if I just choose x and multiply this whole equation times 3, my top equation will stay the same. Second equation with the distribution will give me 9x plus 12y equals negative 6. To eliminate my x's, I would need to subtract, which means I have to subtract everywhere. 9 minus 9 is gone. 12, subtract 12, that's also gone. I'm left with 0 on the left. And then 3 minus minus is change, change. 0 equals 9, and 0 does not equal 9. So this is a no solution exception. There is no answer to that rule. Second option over here, if I take this top equation and multiply by 5, negative 10x minus 20y equals 10. 10x and a negative 10x, I would need to add these equations up and down in order to eliminate my x's. 10's are gone. 20y plus negative 20y, those are gone also. I get 0. And then negative 10 plus 10, 0 equals 0. Anytime you get the same number on both sides, whether it's 0 equals 0 or 7 equals 7, anything, then that means that you've got infinite solutions. as your answer. So those are the two exceptions to the rules when you're dealing with solving with either substitution or elimination. Now, the bulk of this particular chapter is about word problems, so you need to be able to set up a system based on an equation. So in this particular paragraph, we need to make two equations out of this. System means you have two equations. At a pizza restaurant, it costs $4 to make a small pizza that sells for $12. It costs $6 to make a large pizza that sells for $15. In 1 week, the restaurant spent $1,100 making pizzas and sold them for a total of $29.10. How many of each were sold? Well, we have two different things going on here. It's costing us money to make pizzas, so we have to talk about one equation that only deals with cost. And then we're going to have a second equation that's going to be dealing with how much we're selling them for. And then we have to know what it is that we're actually selling. So that's why we talk about you need to identify the variables. In this particular situation, we're making small pizzas and we're making large pizzas. They talk about small pizzas first. Typically, whatever they talk about first, let that one be X. And whatever they talk about second, let that one represent the letter Y. So every equation I write, I need to reference the small pizzas with the letter X. The first equation I write will deal with the cost for everything. So it costs $4 to make a small. That's 4X. And I have now used the 4. It costs me $6 to make a large. So $6 to make a large pizza. So now I am done with the 6. A lot of times it helps to cross things off as you go. And then remember, this entire first equation is only dealing with cost. So it costs $4 to make a small, it costs $6 to make a large, and they spent all together, my total cost for the week is $1,100. And I am now done using that number. My second equation will only deal with selling. What am I going to make when I do all of these? Let's see, the first sentence again, it's I can sell the small pizza for 12. I can sell the large pizza for 15. And I'm going to make a total profit of, or not profit, but I'm going to sell everything for $29.10. And now I have a system set up and I just have to decide how I want to proceed. Typically, elimination is the best way to go for these. Your numbers are going to be larger, so it's a little more difficult to do the substitution method. I could take this whole top equation and multiply by 3. 12x plus 18y equals 3,300. To eliminate the x's, I'll subtract. And remember, you have to subtract everywhere. These are gone. 15 minus 18 is negative 3y, and then 2910 minus 3,300, negative 390, and divide by negative 330. Now remember, when you're dealing a word problem, you need to talk about what these answers represent. So my y term represents large pizzas. So I'm going to sell 130 large pizzas. And then I can go back in, pick either equation you want. I typically pick the ones that are smaller, but you can use whichever one you want. 4x plus 6 times 130 equals 1,100. Multiply 6 times 130, subtract that to the other side. 4x equals 320, and x equals 80. So we're going to make 80 small pizzas. There you go. Word problem. Being able to take a paragraph, write it into a system of equations, and then solve that system using either substitution or elimination. Okay, so there's a brief review for you with section 3.2, solving systems of equations with substitution and elimination.